All right, let's jump right in. There's a revolution happening, but it's not the one you've been reading about. It's not in the cloud, it's not in software. It's happening in the real physical world. And you know what? It's about to kick off this incredible, unprecedented battle for the raw materials that are going to build our future.
So, first things first, what are we even talking about when we say physical AI? Well, think of it like this. It's the moment that artificial intelligence finally gets a body. It's when that powerful AI software gets plugged into robots, into self-driving cars, into autonomous drones, basically any machine that can physically touch, move, and interact with the world around us.
And this quote right here gets to the absolute heart of it. The big story isn't just about code anymore. It's about the literal nuts and bolts. This huge shift from a purely digital world to a physical one is creating this massive new hunger for a very, very specific list of raw materials. These are the physical choke points of this brand new industrial age.
Okay, so to really get our heads around where these choke points are, it's actually super helpful to think of a physical AI system, like a robot or something, as being a lot like the human body. It's got these 4 core parts that we really need to understand.
And this is just a brilliant way to map it all out. First, you've got the circulatory system. That's for power and data. Then you have the brain and senses, which is all about computing and perception. Next up are the muscles. That's for actually doing things, for movement. And finally, you've got endurance, which is all about mobile power. Each one of these depends on a totally unique set of materials.
Let's start with that circulatory system, because it is the absolute foundation for everything else. Copper. The source material calls it the meta investment, and you have to ask, why? Well, it's because every single AI system, and this is just as important, the massive upgrade our power grids and data centers need to even support them, it's all built on copper. There's just no way around it.
And the sheer scale of this is, well, it's staggering. Look at that number. 10 million tons. That's the projected extra copper we're going to need just for AI data centers and automation in the next few years. Now here's the kicker. This tidal wave of demand is about to crash into a market that big players like Goldman Sachs are already saying is heading for a massive supply deficit after 2025.
Okay, so that's the foundation. Let's move up to the brain, the senses, and the muscles of our AI machine. And this is where the story gets way more complicated and honestly, a lot more geopolitically explosive.
Which kind of makes you wonder, right? Just how vulnerable are we? When you really look at the super specialized materials needed for AI's brain, we're talking advanced semiconductors and its muscles, these high-performance magnets. Just how fragile is that whole supply chain?
And wow, this one chart just says it all, doesn't it? The problem isn't just digging stuff out of the ground. No, the real choke point is the incredibly complex, dirty, and technologically tough job of processing rare earth elements into the pure materials you need for powerful magnets. And in that one critical step, China controls something like 90% of the entire global market.
This isn't some theoretical risk. We've already seen the first moves. Back in July 2023, China put export controls on gallium and germanium. So let's just imagine how this could escalate. A full-on export ban could happen maybe late 2024, which would lead to some really intense negotiations and then maybe, just maybe, a suspension way down the line. What this shows is how quickly these materials can go from being simple commodities to becoming powerful tools of foreign policy.
And the potential impact? It is severe. The U.S. Geological Survey actually ran a stress test to see what a full ban would do. The results were a $3.4 billion hit to U.S. GDP, and get this, over 40% of that pain lands right on the semiconductor industry. So the key takeaway here is that this is like a highly targeted economic weapon, and it could send prices for a key material like gallium through the roof, maybe soaring over 150%.
Now, for physical AI to really change the world, it's got to be mobile. Robots, drones, cars, they all need to move. And that brings us to endurance, the battery. And hidden inside that battery is maybe the most difficult and, frankly, the most ethically challenging dilemma in this entire story.
Let's talk about cobalt. On one hand, it is a miracle material for high-performance batteries. It gives you incredible energy density and stability. But on the other hand, its supply chain is an absolute nightmare. It's tied to the political instability of the Democratic Republic of Congo, and it's tainted by these horrific reports of child labor and all sorts of other major environmental, social, and governance, or ESG risks.
And the supply concentration is just extreme. The DRC is, for all practical purposes, the Saudi Arabia of cobalt. It's responsible for over 70% of the world's entire production. Having that kind of dependency on one single unstable source is a massive, massive red flag.
Now here's where it gets really interesting. Just imagine the potential for the DRC to start flexing this geopolitical muscle. Picture a scenario, maybe late 2025, where it sets up a permanent quota system. It would effectively create an OPEC-style cartel just for cobalt. And this could be used to artificially slash the available supply with one clear goal: keeping global prices permanently high.
So, okay, let's recap. We've got a huge deficit in copper, we've got geopolitical weapons like gallium, and we have this ethical minefield with cobalt. Faced with all this complexity, how can we possibly think strategically about what's coming? Well, the source material gives us a fantastic framework for cutting through all that noise.
We can actually map all these materials onto this simple 4-quadrant grid. See, on one axis, you've got geopolitical risk. On the other, you have substitution risk, which is just a fancy way of saying how easily can we replace this stuff with something else. This gives us a really clear strategic map. Down in quadrant 1, you got your low-risk infrastructure like copper. In 2, you have the high-risk geopolitical choke points like gallium. Quadrant 3 is where you find the ESG traps, like cobalt. And then, over in quadrant 4, that's where you find the potential solutions, the disruptors.
And right out of this grid, 3 very clear investment strategies just pop out. First, you've got the picks and shovels play. Just bet on the basics like copper that everybody has to have. Second is geopolitical de-risking. You bet on the new, non-Chinese producers of critical metals who are going to get a ton of support from Western governments. And third, and this might be the most powerful one, you bet on the substitutes, the technologies that just design these problems out of the system entirely.
And that leaves us with one final, and I think, pretty provocative thought. The extreme risks that we see in materials like cobalt and gallium, well, those risks are the very things creating the most powerful financial incentive to innovate a way around them. So the thing you should really take away from all this is that the ultimate choice isn't really about which metal to pick. It's about a much bigger question. Where do you want to place your capital? Are you going to invest in the problem, or are you going to invest in its solution?